Hi friends, welcome to my channel. Let's have a look at another maze problem, that is the maze 3, problem 499. So this problem is marked hard in Leetcode. In this video, we're going to share a solution based on Dijkstra's algorithm, so with the min heap as container. So this problem asks us to return the instructions for the ball to drop into the hole given in the problem statement. And the ball should travel or roll according to the rules here. The rule is specified as here. Let me read it through. The ball can go through the empty spaces by rolling up, down, left, or right, but it won't stop rolling until hitting a ball. When the ball stops, it could choose the next direction. And there is also a hole in this maze, so the ball will drop into the hole if it rolls onto the hole. So that's the rule, and it's also the main point about this problem. So here the problem asks us to return the lexicographically minimum instructions. So let's look at one example to digest. So in example 1, so there are two routes or two instructions which can lead the ball to the hole. For example, left, up, left, or up and left. Because left, up, left is smaller than up, left in lexical order. So the return is LUL. So that's example 1. So similarly, you can look at example 2, which gives a case that is impossible. So the constraints on this problem are mainly the following. So let's pick several of them to digest. So the number of rows and the number of columns of this maze given is between 1 and 100. So the last two actually are some consistency assumptions, which said that both the ball and the hole exist in an empty space, and they will not be in the same position initially. And the maze contains at least two empty spaces. So that's the main statement and the constraints about the problem. So now let's look at the method. Here we're going to use the well-known Dijkstra's algorithm with the min heap as container. So Dijkstra's algorithm is a single source shortest path algorithm. So the key ingredients of the algorithms, or a way to remember this algorithm, are the following. So the first ingredient is the container. So what container do we choose in implementing the algorithm? So here we are going to use min heap. And the second one is relaxation, which we are going to explain. So what's relaxation? So this is the main ingredient in the Dijkstra's algorithm, or similar algorithm alike, like Bellman-Ford. So we assume that du is the current shortest path distance from the source to the generic node u. So here distance, we can divide distance, or so I could put a quotation mark here. So as in this problem, we're going to consider distance at lexical order. So let duv is the edge distance connecting uv directly. And then the following is the so-called relaxation. So if u is reachable and du plus duv is strictly less than dv, then we're going to reset dv to be du plus duv. So the meaning of this reset is that we find a shorter path from source to v by v of the node u. So with the relaxation explained, so let's make some remarks before we look at the code. So first, it might be good or helpful to check analysis videos for Leetcode 505, the second maze problem, or Leetcode 490 in the channel, so first maze problem. Actually, a question is that can you try solving this problem via Bellman-Ford algorithm? So this is a good practice, I would say. And next, we want to point out if we regard this problem is a continuation of Leetcode 505. So what ended in the problem here? Let's see. First, in this problem, we are required to return the instructions by direction, so up, down, left, right, and try to locate the lexical smallest instruction. So in other words, not only to judge if there is a possible path, and also we want to locate how the ball rolls. In this solution here, we shall compare the distance and the instruction pair in the relaxation for getting lexical smallest instruction. So with that said, I guess we are ready to look at the code. So we are going to split the solution into two parts according to the two ingredients of the algorithm. The first is a container and preparation. So I'll see container and dict for storing the distances. So for this, I'm going to first retrieve the information about the number of rows, number of columns. So this is standard. Then I'm going to make a heap, initialize a heap. So using the initial position of the ball. So here the heap will store tuples with 4 components. The first is the distance, because this is the main key where maintaining the heap structure or data structure. So the second one is the instruction. Initially is empty string. And then the third component is the ball row, ball column. So here let me make some remark. So what we are storing is distance, instruction or direction, right? Instruction and row column. So this finished the initialization of the heap. Now we're going to use a dictionary to store the distance and the corresponding instruction from the source to the current position. So let's call it initialize like this: ball 0, ball 1. So this is the key. So it's a tuple, and then the value will also use a tuple. So it's a distance and the corresponding instruction. So let's also make a remark. So here the row, the column is the key, and the distance and the instruction is the value. So notice the order of dist and instruction. So if we want to compare, this will be the first thing we're going to compare. If the distances are the same, then we are trying to select the smallest instruction in lexical order. So that's why we have this order. So with that said, we are finishing the first step. Now let's look at the second step, which is the main loop or relaxation step. For this, we're going to check the while loop, while heap. Then we're going to track the distance, the path for the instruction and the current row and column. That is heap pop, right? Heap pop. So we're popping from the current heap, right? Heap pop. And then first we are going to check if current row and column equals whole. So if this is the case, things are done. So we're going to return the current path, so which is what we did there. Otherwise, we're going to traverse the 4 different directions. So for convenience, let me first initialize the directions and the corresponding instructions. So this corresponding to increment the row index by 1. So this down. This is down, and this corresponding to decrement the row index by 1. This is up, and 0, 1. This corresponding to increasing the column index by 1, so it's right. So the remaining one is 0, -1, decrementing the column index, so it's left. So that's it for the directions. So each of the element consists 3 components. The first component, 2 components, is the directional vector, and the third component is the corresponding plain string instruction. So with that said, let's iterate. So for dr, dc, in, and guide. So I will use guide for instruction. So in directions. Then we're going to pick this direction, dr, dc, and try to walk as long as we can. So for that, let me initialize new r, new c, and new d. And so I'll set as rc and dist. So I want to increment the dist along the new d along the direction dr, dc. So that's basically a while loop. So here I'm going to check the condition for coordinates with increment. In other words, with increment of dr, dc. So actually we can also check without decrement, but we need to one step back when we exit the while loop. So you can check the solution for Leetcode 505 to see this remark. So this is the while loop. So while 0 less or equal than new r plus dr less than m, and 0 less or equal than new c plus dc less than n, and maze. So the current position new r plus dr, new c plus dc, so is not equal to 1, and new r, new c does not equal to whole. So this new r and new c is the position we're going to change direction, right? So then after this, what we want to do, actually we want to, in this while loop, we are going to increment this new r, new c, and correspondingly increment the new d. So by new r plus dr, new c plus dc, and new d plus 1 each time. So that's it. So let me change a little bit so that you can see it clearly. So once we exit this while loop, then we are at a position new r and new c, which is not a whole. So this position is reachable, and we want to do relaxation. So this is the relaxation. So what we want to do is that if new r, new c as a tuple not visited, or so let's make a comparison. So right, so new d. So this is the dist plus this increment in the while loop resulted in new d, and pass plus the current guide is less than visited new r, new c. Then we're going to replace this visit new r, new c with a smaller value, which is this tuple. And then what we want to do is that we want to put this tuple, the corresponding 4-element tuple, to the heap. So heap q, heap push. So the thing we are going to, this is target, and the thing we want to push is new d pass plus the current guide, so, and new r, new c. So that way we finished the while loop. If there are some instruction returned in the process, it means that there is a valid path and a shortest instruction. Not shortest, and lexically smallest instruction. If there's nothing is already returned, so we're going to return, according to the problem, is called impossible. Let's write it correctly, impossible. So that's the full solution code, or a format of solution to this problem. Let's do a special case check. Oh yeah, it passes the one special case. Now let's do a generic case check. Yeah, it passes the generic case. So I guess let's make a quick summary. So first is that in order to better remember the Dijkstra algorithm and practice, so we need to keep in mind two components. One is the container, one is the main step, that is relaxation. And in this solution, we actually write the code according to these two pieces of information. So first, we initialize the container and the dictionary for sorting distances. And in the second step, which is the main step, we are doing relaxation. So afterwards, we return impossible according to the problem requirement. So with that said, I guess that's about it for this video. So if you find this video is useful, you are welcome to share this video with your friends, or watch for other videos in my channel for more information, for discussions or comments. Thank you very much.